Hey guys, welcome back. So this is kind of one of the last lessons. We're down the home stretch now. So today we're going to do modeling with quadratics. And I really just want to go over the basics with you guys. There's going to be 3 problems that you're going to do at the end, and you're going to submit them on Edpuzzle. But other than that, you don't really have anything to submit to Classroom. You're just going to try these problems and see if you can get them right at the end. So modeling with quadratics, we're going to do a few examples, and then I'm going to have you guys go out on your own. So number 1, it says Colin is building a rectangular deck on the back of his family's house. He has enough lumber for the deck to be 144 square feet. The length should be 10 more feet than its width. What should the dimensions of the deck be? So I'm looking for some key words. Rectangular is a big one, so I can draw the rectangular one. And I know the length, or area, length should be 10 feet more than its width. Dimensions means I'm going to find area, so area would be length times width. They give you the actual answer, but I know this is going to be x plus 10 because it's 10 more than the width. So now I can set up my problem. 144 equals x times x plus 10 because I'm going to take the length times the width to find my area. When you do this, you get 144 equals x squared plus 10x. Now it's starting to look like a quadratic problem, but in order to solve it, because I'm looking for solutions, I'm going to have to get 0 on one side. So now I'm going to have 0 equals x squared plus 10x minus 144. If you look at this problem, I'm probably going to end up factoring. So I'm going to list the factors in negative 144. The smaller number is going to be negative because I have a positive in the middle. So now which of those adds up to 10? It's going to be that one right there. So when I factor it and solve it, I got x minus 8, x plus 18 equal to 0. So we get x equals 8 and x equals negative 18. Now when we're talking about dimensions, do I want to use a positive or a negative number? Well, you're not going to use a negative length, so my answer is really going to be 8 that I'm going to plug in. So now I'm going to plug in 8. I know the width is 8 feet because it was just x, but the length was x plus 10, so I'm going to get 18 feet. So the dimensions should be 8 feet by 18 feet. And that's how you would do that problem. So that's kind of what they're looking for when they do quadratic formula using area. So we're looking for solutions. Example 2 says Stephanie is in a snowboarding competition. The equation h equals negative 16t squared plus 30t plus 10 models Stephanie's height h in feet in the air after t seconds. Well, the big thing that we know we can do is that the 10 represents her y-intercept. So the y-intercept is going to be 10. So I drew a picture. The general shape of the graph, we don't know the actual shape, but it would look something like that. That's what we're guessing. So the first question, it says, how long is Stephanie in the air? What they really want to know is, when does Stephanie land? So right here we're looking for solutions. So automatically we're going to set this equal to 0, the equation they gave us, and figure out what it is. Now when you see numbers like this, you're probably going to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I solve both of those, so I got plus the square root of 1540 over negative 32 and minus the square root of 1540 over negative 32. So one gives you a negative answer, one gives you a positive answer. If you think about time, because that's what you're solving for here, I'm probably going to want the one that's positive, so positive time. Now you have to plug this back in eventually to figure out what she is reaching. So the first one is how long is Stephanie in the air? Well, she's not going to be in the air for a negative time, so we know it's 2.16 seconds. Second question says, when will Stephanie reach a height of 15 feet? Well, we know our answer, instead of equaling 0 this time, is going to equal 15. So we're going to use the same equation that I did in the top right. But now instead of 0, we're going to use 15. So I'm going to subtract 15 over. And now you can use the quadratic formula again. Now on this one, you're going to get two answers. I'm not going to do it for the sake of time. But they both make sense. And that's fine, because it would make sense that if she got to 15 feet and then 15 feet, going up and then coming down. Now the last part, it says to earn bonus points in the competition, you must reach a height of 20 feet. Will Stephanie earn bonus points? So what we're going to do is now we're going to find the vertex to figure out if Stephanie can reach a height of 20 feet, because the vertex is going to be her highest point. Right? So if you remember, it's x equals negative b over 2a for our vertex. So when I do that, I get negative 30 over negative 32, which is 0.94. Now, I'm going to plug that in to figure out if she reaches that height. So now I have her height equals negative 16 times 0.94 squared plus 30 times 0.94 plus 10. When you do that, you get Stephanie reaches a height of 24 feet. So did she reach a height of 20 feet to earn the bonus points? The answer is yes, because the highest she gets is 24 feet. All right, so example 3, this is a diver jumps off a high platform at an initial velocity of 16 feet per second. They give us an equation. How many feet above the platform will the diver be at the highest point of his dive? Well, highest point usually means vertex. So negative b over 2a, so I'm going to plug it in. You end up getting 1/2. Now, that's not your answer, because I'm going to plug that in for the t. You should say t equals, and solve it. So negative 16 times 0.5 squared plus 16 times 0.5 plus 30 to give me the actual height. So the highest point is 34 feet whenever you solve that. Now it wants to know how many feet above the platform. Well, the platform is your y-intercept. So if you think about it, your platform is 30 feet. So how much higher did I get than the platform? The answer would be technically 4 feet, because I did 34, my highest point in the vertex, minus where I started, my 30 feet. So some keywords that you're looking for, guys. If it says highest or lowest point in the problem, you're going to use vertex, and you're probably going to plug it in. That's what we did on the last two problems. If it says how long before you reach the ground or how long are you in the air, we're going to use the quadratic formula. I gave you the area formula, and if they give you a height or a time, we just plug it in and solve usually. So those are some keywords that you're looking for when we do these word problems. Again, this is just an intro. I want you guys to try these. So I'm going to give you 3 problems and make them open-ended, and I want you to try them. So homework problem number 1. It says Courtney is building a rectangular wading pool. She wants the area of the bottom of the pool to be 54 feet squared. She also wants the length of the pool to be 3 feet longer than twice its width. What are the dimensions of the pool? Okay, that's problem number 1. Problem number 2. It says a ball is thrown into the air with an initial upward velocity of 48 feet per second. Its height h in feet after t seconds is given by the function. They give you the equation. So I want to know what height will the ball be when 2 seconds has passed, and how many seconds will the ball reach its maximum height, and what is the ball's maximum height. Again, think about the keywords, what it's asking in each question. So there's 3 answers to this one. In problem number 3, it says a skyrocket roller coaster takes riders straight up and then turns straight down. The equation h equals negative 16t squared plus 185t models the height h in feet of the coaster after t seconds. How long is it until the coaster returns to the bottom? So think about what it's asking, look for those key words, and try and solve this problem. And that is your intro for word problems using quadratics. If you guys have any questions, please let me know. Make sure you're getting all your other work done. Try and get that quiz done. That's the last big grade before the end of the year. Have a good day, guys.